Okay, Ella, let's embark on this. So, let's see. They tell us that we have two objects. We have water, and we have this sample, some kind of tin sample. They give us the mass for water, initial temperature. Here you go. Here you go. Mass of water, 115 grams or 115 kilograms. Initial temperature for water was 10 degrees Celsius, and the sample had a mass of 0.225 kilograms and an initial temperature of 97.5. And we're also given the CP for the sample, and we know that CP for water is 4186. We need to figure out the final temperature. So we have this container with water, filled with water, and we have the sample in there. And so what happens is that obviously since this one is hotter and this one is colder, energy is going to start flowing out of the sample and into the water. And there is no energy loss. So that tells us, since there is no energy loss, that there are only two Qs. There is Q for water, and Q for water is going to be a positive Q because water is going to be warming up. And then there will be Q for the sample, and the Q for the sample is going to be negative because, as you see this arrow right here, it's losing energy. So Q for the sample is going to be negative. So positive Q for water and negative Q for the sample. These two Qs are going to add up to 0. Or, as you had it in your video, you had Q1 equals negative of Q2. It works only if you have two objects. Sometimes you have more than two objects, or sometimes you have the loss of energy. So it will probably make more sense to just add up every Q that you have there and then set it equal to 0 just to begin with. All right, so now let's write out what each Q consists of. So for water, we have CP for water, mass for water, CP times mass times the change in temperature. Change in temperature is the final minus initial temperature of water. That's our Q for water right there. Then we have Q for the sample, which is CP for sample, mass of sample, and the change in temperature for the sample. All that equals 0. So then, oh, by the way, I wanted to tell you not to use delta T as in lowercase t, because that stands for time, and sometimes we have both, and it just will mess you up. So just use capital T for temperature. All right, so now we're going to first of all distribute. So what we're going to do is we're going to use CP times mass and multiplied by T final. Then we used CP times mass and multiplied by temperature initial. So this right here, this part kind of unwraps into this, and let's see if I can change. All right, so, and then this part over here turns into, didn't change the color, oh well, turns into this one. So I'm just going to do a double. So this part turns into this. And then I'm just going to go ahead and color code it later on. So moving on to the next slide. So this is where we stopped. This is after we unwrapped those. And what I'm going to do now, I'm going to color code. So everything that has T final in it, which is this has T final and that has T final. This is our X. This is what we're looking for. This is what we don't know. And then these guys consist of numbers. We have all the numbers for them. So I yellowed everything that we do not know and greened everything that we do know. And as you see, the green parts that have the known temperatures, the known initial temperatures, these components have a minus in front of them. And so what I'm going to do, I'm going to take these two and put them on the other side of the equation. So when you move something on the other side of the equation, it becomes positive if it was negative, and if it was positive, it will become negative. So this way, by moving it to the right, we will make these components positive. And then here, I'm going to take T final and T final and put it in front of the parentheses, and put these two factors, because this is our x, and then those are known numbers, and this is also our x, same x, because it's t final, t final. So these are two factors. It's like saying this is 5x and this is 3x, and so I can say that it's x times 3 plus 5. So here it goes. I put t final, put everything that had that t final had as factors. So we had Cp of water times mass of water plus Cp of sample plus mass of sample. On the other side of the equation mark, or the equation sign, we have known numbers. They were negative before, now they will be positive. And so I'm just going to rearrange this. Since I'm looking for t final itself, this right here will become my numerator, and then that which was in brackets will become my denominator. And so then I will put in numbers. So that's my Cp of water, that's my mass of water, that's my initial temperature of water, Cp of the sample, mass of the sample, initial energy of the sample. And then this is my denominator, Cp of water, mass of water, Cp of sample, mass of sample. When you put all this into your calculator, don't forget to parenthesize. Or you can calculate the numerator first, denominator second, and then just divide numerator by denominator, and that should give you 18.5. There you go.